That was really good. I wish I'd recorded all of that. You did a great job working through that with me. Morning, Christopher. You're welcome to work with us here. We're going to be going through some homework questions. If you want to get into the lecture, I've got that posted as well. Or if you want to work on your homework quietly, you can jump into the homework room. Okay, so talk to me about this one here. What are we thinking?
I don't know. I usually just use this little thing over here.
Okay, let's see if we can try doing it without that first. Like, let's give it a shot, and then that might save some time, okay?
Okay.
Okay, so first, do you remember what it is to be the standard form of a circle?
No.
Okay, I'm going to give you a thing that's going to help to remember it. Do you remember the shape that I said you could use? Like, all circles are really this other shape. Do you remember that other shape?
Wait, can you say it again?
Sure, all circles are actually made up of another shape. Do you know what that other shape is?
No.
It's made up of triangles. They're made up of right triangles. So if you think of every single point as being a little bit going sideways and a little bit going up, if you connect all of those, you can connect to those sides in a triangle. So do you remember what the Pythagorean theorem is, that equation that talks about triangles?
The a squared plus b squared equals c squared.
Exactly. That's exactly what we're going to use is the triangle part weird here. Let me take over the screen and then we'll jump right back to yours. So you're going to have to share it back in just a moment, but I'm going to show you what I'm talking about. If I wanted to make a circle and I wanted to pick a point on the circle, here's my coordinate plane. Here's my circle. Pick any point you want. Go ahead and pick a point on that. Draw on the whiteboard. There it is. Perfect. Okay. Look at this. I'm gonna draw a triangle from it. I'm gonna start at the middle. This is my center. If I go up to the point that you have, that's going to be one part of my triangle. If I go straight down and I talk about the height of that triangle, that's another part, and then I got this sideways part. So here you go. This is my A, this is my B, and this is my C. So that I could talk about this as A squared plus B squared equals C squared, right?
Mm-hmm.
Okay, so I can do this for any point. I can do this over here as well. There we are. So imagine that I had some kind of like x value right here. Is it true that the side length here is nothing more than looking at the difference between where my x value is and where the center is?
Mm-hmm.
And I could do that same thing for the y value, right?
Yeah.
So we got 0, 4, and 1, negative 3. So if I was going to put that again on my coordinate plane, I've got 0, 4 is, I go over 0, I go up 4, 1, 2, 3, and 4. And then 1, 3 would be I go over 1, I go down 3. 1, 2, 3, that's going to be right here. So I'm looking for this as being one of the places where my radius pops in, and then this would be essentially the circle we're talking about, true?
Yeah.
Okay, I'm checking in because this is my center, so that's what I put right there, and this was my point, so I'll put that down somewhere on the circle, and then I'll draw a circle. Is that okay?
Mm-hmm.
Now, here's the pattern I recognize when I look at this. Do you see that I could draw another right triangle just like this?
You said draw another right triangle like that.
Yeah, do you see that?
Mm-hmm.
Okay, let's do that exact same thing. That right triangle means, again, I have a squared plus b squared equals c squared, right?
Mm-hmm.
But in this case, c squared is really talking about my radius squared, isn't it?
Mm-hmm.
All right. So we're going to replace that c. We'll put in r instead. So let's work through this one. How long is, maybe I'll call this one a. How tall is it? What's the height difference between a, or between the center here, and p? What is the height difference between this point and this point?
Would it be? Oh shoot.
Say that one again. It was a little quiet.
Is it 7?
How'd you do that?
I added 4 and negative 3.
Okay, well, 4 plus negative 3 wouldn't get me 7. I'll tell you what, you have the right answer. Let's figure out how we did that so we can write that down as a shortcut for the future. How did you get that?
How did I get 7?
Yep.
I added 4 and 3.
Perfect. That's what I'm talking about. Watch this. So you added 4 and 3. Now, some people might say, how'd you know it was 3? Because here it was a -3. I'm going to fill in that gap here. You can always think of the difference between 2 points, and we agree that there's a difference in height here, right?
Mm-hmm.
And difference, what's the math word for difference?
Subtract.
You would. So that's really another way of thinking about what you did, is you subtracted -3 from 4. Do you see how that is going to get you 4 plus 3, which gets you 7?
Mm-hmm.
That's a way that you can think of it from now on. So either way, you've got 7 here for your 7 squared. That's pretty good. Let's now use this shortcut to find out what's the distance here. So P is at the point 1 comma -3. Which of these is my sideways distance, the 1 or the -3?
The 1.
The 1. Good. This one up here is at 0 comma 4. Which one's the sideways distance?
0.
And what's the difference between those two?
7.
What's the difference between the sideways distance?
Oh, it's 1.
It is. That's from 1 minus 0, right?
Yeah.
So there you go. So now we're kind of taking it away. We don't even need the picture so much anymore. If we get comfortable with saying I can just subtract the 2, then I can say, no problem. This is just 1 squared right here. And then that would be my radius squared, right?
Mm-hmm.
All right. And then I would need to find out what my radius is. If we could solve that out. What's 7 squared?
49.
49. And then 1 squared would be,
1.
and that would be r squared, right?
Mm-hmm.
All right. So that means that 50 is always going to be r squared for my entire circle, because it was always like all of these points, no matter any other point that I'd chosen, that length has to stay the same, true?
Mm-hmm.
All right, so in your equation so far, you have x minus 0 squared plus y minus 4 squared equals, so what is c squared?
50.
It is 50. See, you got that right on the dot. This holds all of the information of a circle in here. It says I made it from making triangles. Those triangles were centered at a certain place so that I always got the right lengths. And the length of the radius squared was always 50.
Okay.
Okay? Now I'm going to show you how we can do this a little bit faster in the future. Now that you've kind of shown me that we can think through this one, I'm going to show you how we can do them faster with everything we've learned. You ready?
Mm-hmm.
All right. This is why I like to kind of move away from like the get help parts on the math lab, because if we can go faster than that, then we don't need it anymore. I think the points were 0, 4, and 1, -3. Is that fair?
Yeah.
Okay. Here's the things that I recognize that we have done so far. First, you can set up the structure immediately, right? Because it's always going to be x minus the center, so x minus 0 squared plus y minus 4 squared equals r squared, right? And that's just from me remembering that this comes from triangles. True?
Mm-hmm.
All right. Then you just need to find r squared. And you said that r squared comes from, again, a triangle. So it's going to be the difference between the two x values squared and the difference between the two y values squared is going to be r squared. And so once you did all that, I think you got that that was 50. And so then you just erase this part in the top right and you say, never mind. All of this right here is now just going to be equal to 50. Didn't even need to draw a single picture because you knew where everything was coming from in your logic. Do you see how that worked?
Mm-hmm.
Okay, so now on the next couple of problems, you can use that. All you need to do is think about what is it that it's asking me, what is it that it's giving me, and you are really just going to be drawing a whole bunch of triangles. And if anytime you're confused about what it is, put it onto a picture and see if you can find a triangle. Cool?
Mm-hmm.
All right. That was fun. I liked working on that one with you. Does it feel like that makes a little bit more sense now?
Yeah.
Cool. Love that.
Where you get the y minus 4 from? Like, plus 4.
Oh, good question. So Ajane, can you speak to that one? Why is it that here we did y minus 4? Do you remember where that came from in our picture?
Yeah.
Where'd that come from?
It came from the distance.
Yes, it did. Perfect. So here was the radius. This was me drawing between my center and my point. Here was my center. Here was my point. And so here's the question I would ask you, Daryl. If I wanted to know what the distance is away in my vertical here, how would you find out how far away that is?
Just counting like spots the way it is.
You could count it, but there's a faster way to do that if you can pay attention to what the meaning is behind it. And so the faster way to do it is instead of counting it, you can just realize that what you're looking for here in distance is really the difference between those two, right? Like if I say, what's the difference between 5 and 20, you'd say it's 15, and that's how many spots I have between 5 and 20, true?
Yeah.
And if I wanted to know what's the distance -5 and 10, you could do 10 minus a -5, and that would be 15 spots of difference.
Right.
So you can actually always what the difference is, the distance between them, getting, it'll be a positive or negative distance, but you can always figure out the positive or negative distance by just doing subtraction. You don't even have to count.
You could do -3.
You could. Yep, exactly. But here, what we did in this one was we did y minus 4. And the reason why we did y minus 4 is because we wanted to talk about any point, even these future points that are all going to appear on the circle. We want to figure out the difference between those points and the center as well. And so if these points are just going to be some x value and some y value, then the difference between the heights is always going to be the center minus y, or y minus the center. It's kind of crazy when you realize you can do all of that from just doing subtraction, right?
Mm-hmm.
Bree, how are you feeling?
I'm feeling okay.
What'd you think about that? Did that make sense as to why that is?
Yes, yeah,
Okay.
I got that.
So when you're looking at all of the structures for the circle, you don't have to memorize a thing. You've already got it in your memory. This is nothing more than a squared plus b squared equals c squared. But you now are putting some details behind how you're using this structure. You're saying, oh, my a squared is going to be the side of my triangle, and that triangle is always going to be the difference in my x values. And you're saying b squared is always going to be the other side of my triangle, and that other side of my triangle is always created in the difference of my y values. So that's what I'm going to put here. And then r squared is always going to be the hypotenuse of this triangle. And I'm always going to find that to be, oh, just the same number as any other place in the circle, so I could just use some points and figure that out once and be done.
So, in the problem that you just did, how come you used the point that it passes through to get the radius rather than the center?
Dariel, do you know the answer to that question?
Wait,
So I think the question was, why is it that in this equation here, when we were trying to calculate the radius, why did we use this point right here? True?
Mm-hmm.
probably. Is it because it's like on the circle?
Okay, so we got that points right here is on the circle. This is the radius. What else did I have to use to figure out the length of this radius? This radius was the distance between this point P and what other point?
The center.
C, the center. So do you notice here, Bree, what it is that we have the center is 0 and 4, and then I have the point is my 1 and my -3, and all I'm finding for my distance is the difference, the subtraction between them.
Oh, okay, yeah.
But that's just because I'm using with what I had. If I was given two different points on the circle, I'd have to be a little bit more strategic. Maybe I'd have to find the distance between both of those first and then cut it in half, right?
Gotcha.
So you're all about trying to find the things you need from the things you have. This is a perfect example of where getting good at math will help you in fields that are not math, because we're trying to figure out how to be creative with the tools in front of us. It doesn't matter that we're talking about circles. It's about, can we think beyond what's in front of us to what we know and what we can apply.
Mm-hmm. Okay. Yeah, that makes a lot more sense than the way the homework question help thing
Yeah, I'm not a
does it.
huge fan of that in general because it just simply says this is what you do, but then it's like you have to memorize 14 different things when all we really
Yeah,
need to memorize is nothing. You already all know this. You know the Pythagorean theorem.
right. Yeah,
Why would you spend time memorizing 15 things that are just the Pythagorean theorem repackaged?
exactly. Yeah, that makes a lot of sense.
Love that. All right, Bree, when you find what you got, let's put it on the board, or I'll
Okay.
erase this and we'll talk through it.
Okay, so this one says find the standard form of the equation of the circle with the endpoints of a diameter at the points 5, 6 and -7, 4.
Okay, so here's immediately what I'm doing because you've just overloaded my brain. I honestly can't keep track of everything you've just said. So I'm going to
Yeah.
put it into a picture. Cool?
Yes.
All right, I've got a circle. It says I have a circle. That's an easy win, right?
Yes.
All right, so I've got a circle. It says I've got 2 points that are on a diameter. True?
Yes.
I don't even know that this is exactly where the points are. I don't care. I'm about to just pull out the numbers, so I don't even care that my picture is accurate. Cool?
Okay.
And I
Yeah.
know that I'm just going to have to give these titles. I call this one point P and this one point P. No, that's going to be too confusing. I'll call this one P1 and P2. Cool?
Okay. Yeah.
All right, point 1 and point 2. Tell me what point 1 was.
5, 6.
Love that. So I'm going to put 5, 6, and point 2 is going to be
-7, 4.
-7, 4. Now, I have no idea if these are in the right spots. I don't care that they're in the right spots. All I know is that I'm about to use triangles to help me get at the meaning of this circle, right? And triangles
Yeah.
come from a squared plus b squared equals c squared, since all that a circle is, you can hang out here a little bit, Diamond, if you want to listen to us talk through. We've only got about 4 minutes left of class. So we got like the distances here, this a squared plus b squared equals c squared, and I'm about to start kind of saying, okay, but I need to talk about this in terms of circle, right? And so my
Yeah.
circle is always going to be, let's see, a distance away. It's defined by the radius, first of all, true?
Yeah.
Okay, so I'm going to put the radius somewhere, probably over here with this r squared instead of c squared, right?
Yeah.
If that's my radius, then that means this is a side of a leg, that's a side of a triangle, and so this is going to be x minus a center, wherever that center is. I don't know yet. I'll call that C and say that I'm going to label that as h comma k because I need some more letters, so I'll call it that. So it's going to be the difference between the center and a point. So x minus h is the distance between some point x and the center h. And then here I've got the distance between y and k, which is the distance between any point and the center's y value. And this is where I get my structure from, right?
Yeah.
All right. I have not remembered a thing. I just figured it back out. So if you all forget it on the test, that's cool. Figure it back out. But now what I need to find out is all of these details. So how could we go about finding where the center is? Because I need that and I need the radius. Those are the only 2 pieces of information I need.
Mhm.
What do you think? What would you see? You can use the picture, you can use the numbers, you can use your rules. Just tie it all in together.
Um, I have no idea.
Okay, well look at the picture. If I gave you P1 and P2 and a piece of string, how would you find out where the center is?
Cut it in half.
You would cut it in half. Let's do that. You ready?
Okay.
If I wanted you to cut in half the difference or the distance between 0 and 6, you would say no problem. That's going to be halfway between them. We'll call that 3, right?
Mhm.
And
Yeah.
if I said find me the difference, the halfway mark between -2 and 8, you'd say no problem. That's going to be, let's see, I would go 2 steps into here. That would get me back to 0, and I would balance that with 2 steps in from here. That would get me back to 6, and again, halfway between 6 and 3 is, or 6 and 0 is 3. True?
Yeah.
So what you've done in here is found a procedure. The procedure is take a number, subtract away any of the negatives, and then divide it by 2. In other words, take a number, add it to the other number, and divide it by 2.
Okay.
So here we kind of found a brand new perspective, a change in our perspective. Finding a halfway point between numbers is no different than finding the average of them. That's literally the exact same thing, just with 2 different perspectives. Did you know that?
I guess that makes sense.
Yeah. So here's what we're going to do to find the center. We're going to do the exact same thing. We'll do it for the x values. So we'll look for the halfway mark between 5 and -7. What do you think that would be?
-2.
How did you do that?
I added 5 to -7.
Okay, so that's going to add 5 to -7. That's going to be enough that I kind of get my resulting 0 to number part of it, and then we still need to cut it in half.
Okay.
So that would be, I think, -2 over 2 gets me -1.
Yeah.
Let's check that on a number line to see if that makes sense. You said that I had -7, I had a 5. I'm going to go 5 steps in, 2, 3, 4, 5, until I get to 0, and I'm going to go 5 steps in this way till I get to -2, right?
Mm-hmm.
And the halfway mark between those would be?
-1.
There you go. So the procedure is working well. So I've got the part of my center. The center is now going to be -1, comma, what's the next one? What's the halfway distance between 4 and 6?
1.
What's the halfway distance? What's the halfway number between 4 and 6?
5.
5. Doesn't that make sense?
Yeah.
And it happens from what? 4 plus 6 divided by 2 gets you 5.
Okay.
Okay, so you get your center, no problem. We're starting to fill out our structure. X minus h. H is -1. So I'm going to put in minus and -1. Okay?
Mm-hmm.
Squared. And then I got plus y minus k. That'd be y what?
-5.
Very nice. And then you need to find your radius squared. Remember how to find the distance between a point and the center? We did it in the last problem.
You plug in one of the points to the x and y values.
You find a little mini triangle. Do you see this triangle right here?
Yeah.
How do we find out how long that side length is, or that hypotenuse? It would be the difference again in the x values, which would be what, between -7 and -1. That would be -7 minus a -1 squared for a squared, and then plus
Mhm.
b squared would be the difference between the x values. That'd be 5 minus 4 squared equals c squared, where c squared is my radius squared, isn't it?
Yeah.
So here you have a number you could get that equals r squared, and if you plug it in right there, you're done.
Okay. Got it. That makes
All of
sense.
this down here was us just doing exploring. This isn't a thing that we should need to do every time. Everything that we did up on the top here, this is the shortest way we could solve a problem, and this picture really is optional. You don't have to do this after you start getting an understanding of what it looks like in your mind. So it's like,
Okay.
this was copied, this was copied, this was written, but we really did this work. I mean, we did like 5 lines of work. So this problem is one that we work to make faster and faster and faster.
Yeah. Okay. Thank you.
Hello, everyone. I'm just letting you know that we're out of class time. So if you want to keep working, of course, keep doing that. I've got to leave real soon. If you have a quick question, I can answer it. In the main room, we did a really good job of some people pulling up their homework, and we literally went question by question through people's homework to help make it faster and easier and save them time. So if you want to do this in the future, go through your homework, find the difficult problems, and we'll bring those up in class and do them together.
All righty. Thank you.
Take care. Brandon, what can I help with?
I'm doing the homework, and I solved out like for the center and the y-intercepts and the x-intercept and the radius, and I wanted to know, do I plot the center and the y-intercepts
For plotting it or for in the equation?
for plotting?
You got to do whatever it asks you to do for plotting it. You can draw a circle any number of ways. If you put the center somewhere and you give me a radius, I can plot a circle. If you give me 2 points on the circle, I could probably figure out the radius from that and then plot a circle. If you give me the intercepts only, that'd be a little bit rough, but I guess I could probably figure it out. So if it's asking you to draw it, you can use whatever tools are in front of you.